Determining the behavior of a polynomial at a zero depends on the multiplicity, and the multiplicity is this number k, which the zero written as a linear factor is raised to. If the value of the multiplicity is odd, it passes through the zero or crosses, and this looks like this. Either it goes down through it from positive to negative, or it goes from negative to positive. For touching, it either starts positive and stays positive, touches right at the zero, or starts negative and stays negative. That is touching the x-axis. We can use this information to very roughly sketch a polynomial. So here we have an example, and we're going to use the zeros and the end behavior to sketch the graph of this polynomial. For the zeros, though, we can determine their behavior at the zeros. I usually like to draw a table for this. So our two zeros here are 2 and negative 3. Multiplicity for 2 is this 2, the 2 squared. It's the squared. So this gives us 2 as the multiplicity. And for x plus 3, we have this invisible 1 there, and the multiplicity is just 1. 2 is even, so it touches at that 0. 1 is odd, so it crosses at that 0. The only other thing we have to figure out is the end behavior. Since this is squared here, and this is just to the first power, it will behave like x cubed, meaning that it'll start down and then end up. And we can use this now to sketch a very rough graph of this. I'll first plot my zeros. So negative 3 and 2. And now I'll start with the end behavior to the left. At negative 3, it says it crosses. And then at 2, it says it just touches, goes up like that. Notice one thing, that I didn't draw any scale on my y-axis. So to see more details than this, we would have to plot more points, but to get a very rough sketch, we can just use the zeros and draw them like this. You can also use the calculator to verify the shape, which I highly recommend when solving these problems.